Okay, so this is where we left off on the last video. So just kind of a quick recap. 2 inscribed angles equals the intercepted arc, or I like doing this so I don't have to mess around with the distributed property. It doesn't matter, it's going to come out to be the same anyway. Or one of these equals half of that measure. So I end up with 31, 31x plus 3 equals 96. 31, 31x equals, it's going to be 93, so x equals 3. So if I check it and I put a 3 in there, so 31 times 3 plus another 3, this does give me 96. Okay, so that's another way of looking at that problem. I have a couple more examples with inscribed angles. So this will be example 2. Get this paper ready. So example 2. Again, you can pause, waiting for me to fill all this stuff in. Okay, so we are going to find the measure of arc SQ. So we know lots of different things. First thing I want to notice is we have an inscribed angle. So I know that this is going to be twice that amount. So 95 times 2 gives me 190. So this orange is 190. And then the only one I'm missing is that piece right here, this pink arc. But I know all the arcs have to add up to 360. So I'm going to do 360 minus 75 and then minus another 108 or 190. 360 minus 75 minus 190 gives me 95. So that gives me 95, quick check. So 95 plus 75 gives me 170. Plus that does give me 360. So that checks. And let's see the last example for this section. This angle is 70. This angle is 49. B, C, and D, and we're looking for the measure of arc CD. So the first thing I notice is that this is a triangle. So I know that the sum of the angles in a triangle has to be 180. So I'm going to do 180 minus the 49 minus the 70, and I get angle B to be 61. I am looking for this intercepted arc, so I'm going to take my 61, or actually I'm going to take my intercepted arc and follow it to whatever angle I have. So it's 61. So this angle is 61, so that means this arc is twice that. So 61 times 2 gives me a measure of 122.